Okay, so you want to learn how to make an easy propane tank without any welding? Well, you're on the right channel. And the purpose of this video is to go in further on how I do this. And I'll go through all the little details and how you can do all this with nothing more than a drill and an angle grinder. And an empty 20-pound propane tank, of course. Which is unfortunately more and more common since they changed the valve codes. And they gave people X amount of time to turn them in, but they didn't tell people they had X amount of time to turn them in. A lot of people got stuck with tanks, which is really unfortunate. But if you're going to build a stove, that just means there's tanks more everywhere. First thing you want to do is devalve it and degas it in a safe, consistent way. I'm not going to tell you how to do that. You do that at your own risk. There's plenty of videos on how to do it safely. Make sure it is empty, completely empty, and purge it out with something, water, air, something. But that's all up to you. Of course, you can get tanks that are already emptied, or you can get tanks that were filled with an inert gas like nitrogen. That might be your best bet, but it's up to you. Okay, 20-pound tank, devalved, degassed. This is a 6-inch flange, like so. This one, I've actually had a hot plate installed here at the top, so I can put a cup of coffee or a pasty there, or whatever I want to heat up, right there, and it's bolted right in. I've matched the angle right here, just by situating it, so that it's flush and that it's horizontal perfectly, so nothing will be tippy or spilling or anything. Flange hole I've just cut with an angle grinder. That's an old industrial flange. You can get a flange with from pretty much anywhere. Any industrial store or hardware store will have pipe flanges, whatever size you want. You can also use a flange right here for your underfire control. And this one is nothing but all thread with the old valve off the gas tank and washer stacked up to fill the hole. And this is actually an old auto exhaust flange that I've just used to cover up the opening that I've cut, and that I can seat this in. So that's closed. That's open. And it actually more or less locks right there. It's closed. You are pretty much 100%. The door, I've always cut the doors off other tanks ever since I learned in the beginning when I first started making stoves. Now you don't want the door the same size, or you're going to have to use a lot of rope seal or something to seal it up, because it's going to leak air and thus leak smoke. You don't want that. And also you can see I didn't exactly put this door in the middle of the tank. I put it further down. So I'll have this air volume to take up when I open the door to put in air or check the fire. That'll have the space up here for the smoke to go, so it doesn't go in my face when I open the door. So the door cut off another tank. You can see how oversized this is here. So that it seals up good. And if you cut it right off the same location off another tank where you cut this door, it'll fit perfectly as long as you grind down these two inside surface welds, because a tank is actually two shells they put together, and they've seamed it in the middle with a big weld here. And you gotta grind down this end and this end so that it doesn't push up against here and make a gap. You see? You see how tight that is? And then my hinge is simply an old door hinge, repurposed, and I've double stacked a couple washers on the back side, so again it's flush to compensate for this thickness of this door, so it doesn't push out and thus create another gap. You can kind of see that right there. And my door latch, it's just a piece of steel strap I cut off something or another. I got an old repurposed spring so it doesn't get hot on my fingers, so I can open and close the door. And this is just another bolt with a double nut so it doesn't spin off, set loose. And I've hooked another piece of strap that I've bent to match this angle so that it closes the door tight. Again, you'll want to bend this a little bit to match your whatever angle you got. You'll have to do it a few times to get a feel for it. Of course, that's true with anything, yes. Before we go inside, let's go to these legs. So I've left the base of the propane tank, as you can see. And I've taken black pipe and I've cut it to the length I wanted, and I took long bolts with washers, as you can see, and drilled through the bottom of the tank, and I've set them against this old base, spaced them perfectly so it doesn't wobble or anything. There you go. And my under fire shot inside the stove, but there you go. Now we'll go inside the tank. So we'll open this up. What we got here? First of all, we got an old piece of something or another. It's off of something, but I made a somewhat primitive air bypasser heat exchanger right there, so that the air has to go up around this thing before it goes out, so it'll retain more heat. See my video on what is a heat exchanger. And then for the underfire grate, I've taken an old piece of heavy grating and cut it to fit so it sits in the bottom to keep my wood off the bottom. And the little bolts sticking up through the black pipe legs helps a little bit with that too, because it helps give something to seat on. The whole stove's been treated in high temp stove paint black, or stove black, some people like to call it. In a minute I'll pick up the camera and I'll do a slow pan around this so you can kind of see better. It's a dreary February winter day here, and even though I'm in the garage doorway to keep the wind off me, there still isn't a whole lot of light. Not like a studio or anything. So I'll apologize for my shakiness, but I'll pick up the camera and pan around this thing real quick and show you what we got here. And yeah, it's true, I don't use any welds or anything, but you really don't want to use a weld on anything with a firebox anyway. That's too harsh of an environment, and eventually the welds are going to fail no matter how perfect they are. That's a myth anyway. There is no perfect weld. Okay, there's welds that hold and welds that don't, and some welds just hold longer than others. And no weld in the world's going to withstand the harsh environment of a firebox. No way. You got alternating periods of heat, cold, moisture, dryness. It's just, you got all the physical forces working against you, and it's all the stuff that loves to crack welds. Besides, bolts are always better. So here we go. I'll grab the camera and do my slow pan here. Give you a close-up of that little mini hot plate and how I just situated it. As you can see, I just bent this enough just to match this angle so it sits here horizontally. 3 bolts through the surface of the stove to secure it. There's my old industrial flange. There's a good detail of those stacked washers behind the hinge so that it will stay flush. You can see just how tight that door is. You could not stick a piece of paper in the gap of that door. That is that tight. Just from doing it right. See that? That's what I'm talking about. And you'll have people tell you, oh, it's going to leak and you got to use rope seal. No, it won't if you do it right. Never leaks. Besides, air is just like water. Air always follows the path of least resistance. So if you give it more resistance here, it's going to go out where it's supposed to. So let's give you some detail of that under fire control. As you can see, the old exhaust flange and the all thread, and how I drilled through the old valve control knob and did that. And there's the stacked washers and stuff inside. You can see how this works. That's closed, open, or I could just set it there and leave it halfway. Real simple control. Don't need anything fancy. I'll give you a close up on the light of this door latch and stuff, and how this is.